Okay, so in the last class we have started with revision. The revision, what we have done was started with the first chapter, and we have seen what is data, what is database management, what is mini world, what are the typical DBMS functionalities, and we'll start now with the characteristics of database approach. So easiest way to remember the 5 characteristics is, so you can remember as SIDSS. So at least you can remember this, right? SIDSS. Then you can recollect what stands for S, what stands for I, what stands for D, what is SS. So that's what here self-describing nature of database. So now you have your USN number. What's your USN numbers? You have 1 BY. So what is 1 BY 19 MCA 0 is your USN number. What is 1 stands for? 1 stands for the region. In Karnataka, which region you are studying? That's the reason 1 stands for region. What is BY? BY is a college code. What is 19? Which year you have joined MCA? Then MCA stands for which branch you are. Then 01 is your roll number. That's how here what the USN have done. It describes its own what actually these details are. So by even the staff or people who are working under VTU, employees, all employees will be knowing, if you know the USN number of a student, they can know, they will be knowing which region they are, which college they are, which year they have joined the course. So that's what here, even when you go for placements, even the employees will be knowing which all these details. So that's the reason self-describing. This USN will describe your complete details. So which year you have started your MCA, which year you are closing. All these details can be calculated by your USN number. That's the reason self-describing nature of the database. The same way, how the database should be, the database should describe itself. So there are 5 main characteristics of database approach. SIDSS, self-describing nature of the database. It is describing its own description, self-describing nature of the database. Then insulation between programs and data. So what is a insulation, how the program is, how the data is, the insulation between programs and the database. So these things, now you should know how the front end, how is back end. That's how your insulation between program and the database. Then what is data abstraction? So now what you people want to see, if you see the Navata textbook, how much big the Navata textbook is, it is around more than so many pages. Are we explaining each and everything? But we are giving you a gist of the DBMS. So what is there in your syllabus, we are teaching, not complete Navate book. Like this, you have so many other DBMS books also. We have Radha Ramakrishna, Navate is there. So like this, there are so many textbooks, but which one is prescribed for you in your syllabus and what is covered, what they have asked us, the VTU asked us to cover, only that much we are covering. That's what here, the same way data abstraction. What is required, only that will be shown to you people. Now ATM, when you go for ATM, only your account you can see, not complete your friend's account you can't see, or complete database you cannot see. That is what is data abstraction. Then support of multiple views of data. So now same way ATM, only you can view your account details, not complete database accounts. So the same way when you, because we are just customer for the bank. In the same way, imagine that if a person is an employee, he is an employee in the bank, then at least he can see complete how many accounts are there, who are those. So that is about employee. Coming back to database designer for the bank, then he'll be knowing complete thing. That is what is a support of multiple views of the data. Then sharing of data and multi-user transaction. So multiple views of a data, how many people can be viewed, how it is being done, that is what is a support of multiple views of the data. Then sharing of data and multi-user transaction processing, how the data is, how the transaction processing will be done. All these we are seeing in the 5 main characteristics of the database approach. Self-describing nature of the database. A DBMS catalog stores the description of a particular database. Example. So what it is describing, what the self-describing nature of the database? It describes a catalog. So it stores what are the information you're stored in a particular database, what is the data structure, what are the types of the data, what is the constraints you have done. So in your data structure, you have studied so many, what is integer, what is float, what is character, what is string, all these you have studied. Same way how we are storing, what type of information we are storing in the database, whether we are storing a character, whether we are storing a number, whether we are storing the audio, all these types also is required along with that constraints. So if I say phone number, how many digits the phone number should take? Can I take 20 digits for the phone number? No, I have to restrict, saying that it should take only 10. So that is what is a self-describing nature of the database. This, the description is called a metadata. So metadata is what it will just describe. Now you in your lab, you're using something called as a describe table. So that is a metadata. It will just describe what the table is doing. So that is what is a metadata. Then metadata and catalog allows the DBMS software to work with different database applications. So that is what is metadata and catalog allow the DBMS software to work with different database applications. So that's what here self-describing nature of the database. Insulation between program and data. So what is this program? How is your front end? How is your back end? What data you're fetching? All these we have to see. It is also called as a program data independence, allowing changing data structure and storage without having to change the DBMS access programs. That is what is called as the insulation between program and the data. Data abstraction, data model is used to hide storage details and present the users with a conceptual view of the database. Programs refers to the data model construct rather than data storage details. That is what is a data abstraction is. There is insulation between program and data. It is also called as program data independence, allowing changing data structure and storage organization without having to change the DBMS access programs. Then what is data abstraction? A data model is used to hide storage details and present the users with a conceptual view of the database. Program refers to the data model construct rather than data storage details. Support of multiple view of a data. Each user may see a different views of a database, which describes only the data of interest to that user. That is support of multiple views of the data. Then sharing of data and multi-user transaction processing, allowing a set of concurrent users to retrieve from and to update the database. Concurrency control within the DBMS guarantees that each transaction is correctly executed or aborted. A recovery subsystem ensures each completed transaction has its effect permanently recorded in the database. Then online transaction processing is a major part of a database application. This allows hundreds of concurrent transactions to execute per second. Next, we move on data users. So database users, how many database users are there? Users may be divided into those who actually use controlling the content. So in your movie, most of us, what we see in the movie, hero, heroine, villain, supporting actor, all this. But we should imagine who are the people working behind the movie also. There are so many people who are investing amount, who is directing, makeup, music. There are so many people who we are not able to see. Same way, even in the database users also, there are actors on the scene and workers behind the scene. So users may be divided into those who actually use and control the content, called actors on the scene, and those who enable the database to be developed and the DBMS software to be designed and implemented, called workers behind the scene. Database users, actors on the scene, database administrators responsible for authorizing access to the database, for coordinating and monitoring its use, acquiring software and hardware resources, controlling its use, and monitoring efficiency of the operations. Database designer responsible to design the content, the structure, the constraint, and functions or transaction against the database. They must communicate with the end user and understand their needs. End user, they use the data for queries, reports, and some of them actually update the database contents. So that is what actors on the scene. A database administrator responsible for authorizing access. So the people who are on the scene, like the same thing I told you. In movie, who are on the scene, most of them hero, heroine, supporting actors. These are the people on the scene. The same way, the people who are actors on the scene. So database administrator responsible for authorizing access to the database, for coordinating and monitoring its use, acquiring software and hardware resources, controlling its use and monitoring efficiency of operations. Database designer responsible to define the content, the structure, the constraints and functions or transactions against the database. They must communicate with the end user and understand their needs. This is what the database designer will be doing. The end user, they use the database data for queries, reports, and some of them actually update the database content. Then categories of the database user. So, casual users, very frequently they may use. So then those people are called as a casual user. Access database occasionally when needed. Navy or parametric, they make up a large section of end user population. They use previously well-defined functions in the form of CAN transaction against the database. Examples are bank teller or reservation clerks who do this activity for an entire shift of operations. So sophisticated.
Hello. Bank manager on that. Bank manager andre everything checks, okay? Every quality will check.
Yes, Srinivas? Srinivas, you are saying something? Srinivas? Srinivas is here?
Ma'am, he's speaking on the side, not this side.
He don't know that is his muted.
Yes,
Okay, fine. I thought he ಏನಾದ್ರೂ ಇಂಟರ್ನೆಟ್ ಪ್ರಾಬ್ಲಮ್ ಆಯ್ತೇನೋ ಪಾಪ ಹೇಳ್ತಾ ಇದ್ದಾರೆ, ಯಾಕೆಂದ್ರೆ ನಮ್ಗೆ ಗೊತ್ತಾಗಲ್ವಲ್ಲ ಈ ಕಡೆ, ನಮ್ಗೆ ನಿಮ್ಗೆ ಇಂಟರ್ನೆಟ್ ಕನೆಕ್ಷನ್ ಹೋಗಿರೋದು ಅದು ನಮ್ಗೆ ಗೊತ್ತಾಗಲ್ಲ. ಸೊ ದಟ್ ಐ ಥಾಟ್ ಐ ಈಸ್ ಸೇಯಿಂಗ್. Okay, fine, thank you. Okay, categories of end user, sophisticated. These include business analyst, scientist, engineers, others thoroughly familiar with the system capacity. Many use tools in the form of software package that work closely with the stored database. Then standalone, mostly maintain personal database. So now you're doing mini projects, PBL projects. Then what database you use? You use your own database, small database you keep, and just for demo purpose, you may use some data and store the data in that, and how to retrieve this you will be doing. So that is what is called as a standalone. Mostly maintain personal database access using ready-to-use packaged application. An application is a tax program user that creates his or her own internal database. That's what we may use. Like this, there are so many applications where we use a standalone applications. And what are the advantages of using the DBMS approach? Controlling redundancy in the data storage and in development and maintenance efforts. So what do we do? What are the advantages of using the database DBMS approach? Controlling redundancy. Now, I cannot say that your 50 people are there. I cannot keep storing your 50 names 50 times. Is it required 50 times to store your names? Not required. So then what we do? We have to remove them. So that is what is called as a redundancy. We have to see in our database only your one time your name and USN should be there, and other time your first semester, second semester, everything, it should be linked. That then we can reduce the data redundancy of data in the database. That is what is called as a controlling redundancy in the data storage and in development and maintenance efforts. Sharing of data among multiple users. So now what we are doing for your exam, for your classes, or even your in the YouTube, we are sharing our details. So in the GCR for your internals, we have shared the question paper. All 50 can access the question paper at the same time. That is what is the sharing of data among multiple users. Now how many users you are 50. So 50 plus users are using the question paper at the same time. That is what is the sharing of data. Similarly, you can see there are so many applications where data, at least now after in a COVID era, most of us are started using online and the sharing has to be done. So that's what you can see even nowadays we started using the Google Drives also, where we start sharing most of our data. So that's how in the similarly even in the database, sharing of data among multiple users. Then restricting unauthorized access to database. Now, how many people can access the login of this? Only third semester students can use this. So then I cannot ask third semester of some other college to attend my class. So that is what I'm restricting. That is what is restricting unauthorized access to the data. Then providing persistent storage for program object. So the database should also be persistent. Then that is what is called as a providing persistent storage. Then providing storage structure for efficient query processing. So now you start, every one of us start using online shopping. Now we start using Amazon, Flipkart. There are so many other applications where we use. So if I want something to buy and if the page starts opening for half an hour, then we don't have patience to sit and do online booking. How we want everything in a fraction of seconds. Then you will see how the database efficiently and processing should be done. So that is what providing storage structure for efficient query processing. Then providing backup and recovery service. So now some days before, maybe you can ask your parents or your grandfather or grandparents how they were tracking their friends' contact number. They were having a book called as a diary where they were writing their names and their mobile numbers. So nowadays, how you people started using your friends' number and thing, even in to keep it a backup, how you are doing. So nowadays, every one of us know how to keep a backup of all the contacts. In case if my mobile is lost, even the situation I have to get back my contact details. So how we are doing? Can anyone help me out? How you people are keeping the contact recovery backup? Anybody? Can anyone say how you are keeping your contact details recovery? So that's what here. Even the contact details can be kept in your Gmail. Not only places where you can keep in a cloud, you can keep in a mails. Sync your details there. So once by chance, if you buy a new mobile, or if you have lost a mobile, then even then also we are able to at least some, may not be 100%, at least some percent of contact details we can fetch. So that's what a backup and recovery service. So in the same way, providing multiple interface. So now, what are the different interfaces we have? There are so many interfaces. Now, what is the interface we are taking one-to-one? So the same, we can use it, the banking, the same I told, ATM, only one person can view his detail, ATM, that is bank details. So whereas the employee in the bank can see his complete, how many accounts are there, who is what is the number, all he can see the account details. That is what the employee. Think of a software person, if the database has been developed by some Oracle company, then he will be having still more information and still different interface will be there. That's what here, providing multiple interface to different class of users. Then complex relationship among data. So in your lab, you have done 5 programs. In that 5 programs, you can see all are different tables, different databases, different things. So then you just think how the relationship among all these is required. Then integrity constraints. So once your USN is entered, I cannot enter again the same USN. So that's what is called as a constraints. Like you have primary key, foreign key, unique. There are so many constraints. We are restricting the data that it should be entered only once. So that is what is a integrity constraints. So then drawing inferences and actions from the stored data using a deductive and active rules. So now I have to draw something. You are drawing the flow charts. You are drawing a year diagram. Why? Why you are writing? So we can infer that these are the inferences, what the stored data and using deductive and action rules. So next we move on historical development of database. So early database applications, there were the hierarchy and network model were introduced in mid 1960s and dominated during 70s. So then a bulk of worldwide database processing still occurs using these models, particularly the hierarchical model. A relational model based system. Relational model was originally introduced in 1970s, was heavily researched and experimented with IBM research and several universities. The relational database products emerged in the early 1980s. So next next database development was object oriented and emerging applications. So you would have seen some years down the line, we were having a how we were storing all this. We were using a disk operating system, that is now you call it as a DOS. So after that we have a Windows. Later on, after some years, we were having a Linux, Unix. So like this, their technologies has increased. In the same way, even in the database also, initially it was a hierarchical, initial parts, early days, it was a hierarchical and network model. Later on, a relational model has came into existence. But after that, again, object-oriented and emerging applications have come into existence. So what is this object-oriented database management system? So ODBMS were introduced in the late 1980s and early 1990s to cater to the needs of complex data processing in CAD and other applications. Now you can see why the CAD is used. You can ask for the civil or civil engineering or architectural engineering the students, minute things also they try to do it, building construction, everything they will do it in the diagram only. But the same thing 50 years down the line, everything they were doing in a drawing sheets. They were drawing everything in the using they were having so many instruments. So nowadays that instruments can be done using a CAD. That's how the accuracy of the data is required. Many relational DBMS have incorporated object database concepts, leading to a new category called as a object relational DBMS. So in this case, what is this DBMS incorporated object-based concepts leading to a new category, that is object relational model? How all these is being done? That's what object-oriented. Then extended relation. Now you can see Flipkart, Amazon has come into this. Not only Flipkart and Amazon, there are so many things. So now because the internet has brought into many areas, so even then the data is required. Now you can see 40 years or 50 years down the line, we were having only radio and only Doordarshan was there. After some years, only some private channels was there. But now you can see how many are there. There are huge number of channels. Which one is truth, which one is false, we don't know. So the same way you can see extended relation system added further capacity, for example, multimedia, XML and other data types. So the same way, data on web and e-commerce application. Just now I told how the data should be on the web. Now, even the match, so your cricket matches, so at least some years down the line, we were at least sitting in front of a TV to watch the match. Nowadays, we don't have time. Then what we have done is, we started checking in the internet or in the mobile only. But what we see, we just see only the scores. So in that case, rest of the page should be there, only the score should be changed. So that is what the web contained data in the HTML with the links among the pages. So now the data is also on the web and e-commerce applications. This has given rise to a new set of applications, and e-commerce is using new standards like XML, extended markup language, script programming language such as PHP and JavaScript allow generations of dynamic web page that are partially generated from a database. Allow database updates through web pages. So then extended database capability, new functionality is being added to a DBMS in the following areas. So scientific applications. So you would have seen in a Mangal movie called, which movie is that? Akshay Kumar is there, where they see what is there in the moon. What is that movie name? I don't remember. So in that movie, you can see how much they work to know what is there in moon. So in that case, they have to use so many scientific applications. That is what is a scientific application. In the same way, XML, extensible markup language. So what is required in a extensible markup language? In the same way, image storage and management. So we store images. Now your Google map is there where it stores your directions, which direction you have to go, what direction you have to go. That will be stored in your Google map. That is like an image. And when you use a map, it will show you the direction, not only direction moving, which direction, arrow marks also, but if the blind people are there, even the voice also is available. That's how here image storage and management. In the same way, audio and video database management. So your movies, songs, all those are also required, right? So in that case, we have to use a audio and video management. So in the same way, next one is data warehousing and data mining. So like this, imagine how much data will be there in the internet and how much which data is important, which data is not important. We have to classify them, and you can just see the prediction. So that's what here COVID-19. Some have to predict when it will go, when the vaccination will come, how many people will be affected. All these are the predictions. So how do we predict? Based on the data. So in that case, we require a data warehousing and a data mining. Then we have something called as a spatial data management. So in this, even in a Google map also, you can see which is the direction or what axis it is, what is longitude, what is the other details also you can see in the Google map. That is what is a spatial data management. Spatial means what? X-axis and Y-axis. Now you draw your graphs. When you draw graph, you draw, at least in your PUC or some other things, you were drawing a graph where x-axis, y-axis, and you were drawing a line, curve, bar graph, pie chart, all these you were drawing. So that is what is a spatial data management. So in the same way, time series and historical data management. So time series. Now if we say time series, now you are in third semester. And in third semester, how many subjects are there? 31, 32, 33, 34, like this we have. So in that case, what is this? Time is being given for each subject 1 hour each day. So that is what, same way here, even in the database also, how much time the data should be there, how much time it should be. You can see, once if you are using some banking database or government database, the session is expired. So why it says? Because they give their only that much time to access that particular thing. If the time is expired, you have to re-log in. That's what here, even in the database also, we can restrict the time. So how much time any person can use the database. That is what a time series. And historical data management, how the data should be managed. So the above gives rise to a new research and development in incorporating new data type, complex data structure, new operations, and storage and indexing schemes in the database system. So that's what here the above gives rise to new research and development in incorporating new data type, complex data structures, new operations, and storage and indexing schemes in database system. Next, we move on to a database system concepts and architecture. So, overview of database language and architecture. So what is data model? A set of concepts to describe the structure of database, the operations for manipulating these structure, and certain constraints that a database should obey. So then that is what is called as a data model. So structure, how should be my database? USN should be first, or serial number should be first. USN, name, your third semester DBMS 31, 32, 33, 34, like this it should be there. So that is what is called as a describing the structure. What operation you want? You want insert the details of all third semester students, DBMS marks, other subjects marks, your USN name marks or attendance. That is what is called as the operations. Then constraints. So how much marks should I enter in the marks column? Should I enter 100? Should I enter 200? So I restrict there. That is what is called as a constraints that the database should obey. Then data model structure and constraint. Constructs are used to define the database structure. Construct typically including elements and their data types as well as groups of elements. Example, entity, record, table. So this is what you can see. Data, what is there now? Asta. What type of data it is? It is a string. What it is? It is a name of particular person. So that's what this is one type of data. Then this we call it as an element. In the same way, entity. I'll say student. I want all third semester students in one table. Then we call it as an entity. Then record. Details of one complete student. USN of one student, Asta's USN number, Asta name, what are her marks, what are her attendance, complete one row is called as a record. Then table, complete third semester, all 50 students details, then we say it as a table. Then what is the relationship among groups? How much is what is 1, what is USN 1, what is USN 2, what is USN 3, what is all this? 19 USN 01, 1 BY 19 NCA 01. What is all these? These are the USN of third semester. What's the relationship between this? Alphabetically order, it is arranged. So this is how the relationship between the groups are being taken. The same way, constraints specifying some restrictions on valid data. These constraints must be enforced at all times. So then, what is data model operations? How do we just told we do operations? What type of operations we can do? These operations are used for specifying database retrieval and updates by referring to the construct of the data model. Operations on the data model may include basic model operations. Example, generic, insert, delete, update, and user-defined operations. Then compute student GPA, update inventory. All these are the operations what you can do. I can insert a student, all third semester student details, or I can remove some students who left in the second semester. I can update. Today you are in third semester. After some months, you'll be into fourth semester. Then we have to update. Then we use a update operation. So in the same way, I want to know what is your credits after your first, second, third, fourth semester. So that's what here we can calculate them. That is what GPA. In the same way, there are so many other operations which we can do on the model. That is what is called as a data model operations. Yes. Then next we have something called as a conceptual or a high level or a semantic data model. Provide concepts that are close to the way many users perceives data, also called entity-based or object-based data model. That is what is called as a conceptual or a high level or a semantic data model. Provide conceptual concepts that are close to the way many users perceive data, also called entity-based or a object-based data model. Physical or a low level or a internal data model provide concepts that describe details of how data is stored in the computer. These are usually specified in an ad hoc manner through DBMS design and administration manual. Then implementation, representational data model provide concepts that fall between the above two used by many commercial DBMS implementation. Examples, relational data model used in many commercial systems. Same history of data model. When was the relational model? When was the network model? When was the hierarchical model? When was the object oriented data model? What are the object relational model? All these which we have seen. So then we can see what is the use, what is the advantage and disadvantage of hierarchical model. So hierarchical model is what? What is hierarchy of our college? Principal, next HOD, next staff, next lab instructors, next housekeeping. Like this, we have a hierarchy of any organization, not only BMSIT. You go for some companies also, there will be some hierarchy. So that is what is called as a hierarchical model. So having this is a good, or not having this is a good. So that's what we see here, advantages and disadvantages. What is the advantage? Hierarchical model is simple to construct and operate on, corresponding to a number of natural hierarchical organized domains. Example, assemblies in manufacturing, personal organizations in companies. Language is simple, uses constructs like get unique, get next within the parent. So like this we use them. That is what is called as a hierarchical model. But what is the disadvantage of hierarchical model? Navigational and procedural nature of processing. Database is visualized as a linear arrangement of records. Little scope for query optimization. So these are the disadvantages of hierarchical model. So in the same way, what are the disadvantages of network model? I'll stop here. We'll continue in the next class. Asta, answer your attendance.
Present, ma'am.
Abhinav, Aishwarya,
Present, ma'am.
Ambarish, Anu, Arbaz, Arjun, Ashok,
Present, ma'am.
Benita,
Present, ma'am.
Bhargavi, Ravishya,
Present, ma'am.
Chaitra,
Present, ma'am.
Devmalai,
Present, ma'am.
Diksha MS, Deepika LG,
Present, ma'am.
Deepika MB,
Present, ma'am.
Murli Krishna,
Present, ma'am.
Gangubai,
Present, ma'am.
Pujia, Harshit,
Present, ma'am.
Junjar,
Present, ma'am.
Kavya,
Present, ma'am.
Kishore,
Present, ma'am.
Lata,
Yes, ma'am.
Manisha, Manjunath,
Present, ma'am.
Nayana, Nilanjan,
Yes, ma'am.
Pavan, Nishant, Pavitra,
Present, ma'am.
Maithili,
Present, ma'am.
Priyanka,
Present, ma'am.
Pavan,
Present, ma'am.
Akash,
Present, ma'am.
Rajeshwari,
Present, ma'am.
Rakesh, Ramya,
Present, ma'am.
Rashmi,
Present, ma'am.
Ravi,
Yes, ma'am.
Rizwan,
Present, ma'am.
Vishal,
Present, ma'am.
Savita,
Yes, ma'am.
Shruti,
Ma'am, 05 present, ma'am.
Sneha,
Yes, ma'am.
Spurti,
Present, ma'am.
Srinidhi, Srinivas.
Present, ma'am.
Sir, you were saying something, sir.
Sorry, ma'am. I was on a call. Sorry.
I thought you were saying my internet is not working. I thought like that.
No,
Ma'am,
sorry,
sir, present, ma'am.
Thank
Yeah, Sunil,
Present, ma'am.
Vaishnavi,
Present, ma'am.
Vinny.
Present, ma'am.
Yeah. Someone was answering.
Ma'am, Gudiya is having mic problem.
Yeah, I have marked.
28
Ma'am.
Uh-huh.
Ma'am, Sunil.
28 ma'am. 1 by
1 BY 28.
yes ma'am.
1 TD 16
Yeah, marked.
present, ma'am.
Huh?
1 TD 16 present, ma'am.
Yes, Shruti.
Yeah, ma'am.
Yeah, marked. Yeah, Sunil marked. Anybody else? Okay. So we'll stop here. We'll continue in the next case.
Ma'am, Anu present, ma'am.
Okay. Okay, Anu. Hello. ಇಲ್ಲ ಹೇಳಮ್ಮ ಕ್ಲಾಸ್ ಇತ್ತು ಮುಗೀತು ಹೇಳ